Class 11th topic gravitational potential energy. Now before we start with this topic, we need to understand one very important thing, that whenever we calculate any kind of potential energy, we follow certain steps. And what are these steps? We know that energy and work are equivalent. So if you want to calculate energy, you first calculate the work done. Now work we know is given by F dot S. So if the force involved in the situation is constant, you can directly substitute in this expression. But if the force involved is a variable force, in that case we calculate first the small work done for a small displacement, and then we integrate that expression to calculate the total work done. And this work done, we say, gets stored in the form of potential energy. Now coming back to gravitational potential energy, we already know that potential energy is the energy possessed by a body by virtue of its position or shape. And in this particular case, it is the position. Now suppose you have a system of two particles m1 and m2 separated by a distance r. So to calculate the potential energy associated with this system, we have to calculate the work done to create this system in this particular configuration. For that, what we generally do, we bring m1 first at a particular position A. Now since there is no particle present right now, so we can say that the work done to bring m1 will be 0. Now when you bring the other particle m2, already you have m1 present here. So m1 will have a field around it. So you are bringing the particle m2 from infinity to this point B, which is at a distance r from A. This work done gets stored in the form of potential energy. So how can we define gravitational potential energy? Gravitational potential energy of a body is the energy associated with it due to its position in the gravitational field of another body. And how do we measure it? It is measured by the amount of work done in bringing a body from infinity to a particular point in the gravitational field of other. So let us derive the expression for gravitational potential energy. Now we'll consider our first body as Earth, which is fixed. Okay, and let us assume that the Earth is a uniform sphere of mass capital M and radius r. Now we wish to calculate the potential energy of a body of mass m located at point P such that OP is equal to r. Now by definition, you know that gravitational potential energy of this body is the work done in bringing this body from infinity to this point P. Now suppose at any instant this body is at point A, which is at a distance x from the center of the Earth. Now using Newton's law of gravitation, the force of attraction on the body at point A is given as the gravitational force F is equal to gmm by x square, and this force will be towards the Earth, that is towards AO. Now let us say that under the action of this force there is an elementary displacement dx, that is the body moves from point A to point B, and during this displacement the value of force is nearly constant. The small work done by F in moving the body from A to B is given as, now the direction of force is towards AO as well as the displacement is also towards AO. So the angle between them will be 0. So you can simply write this as F dx. Now putting the value of F, what do we get? gmm by x square dx. And if you want to calculate the total work done in bringing this body from infinity to point P, we have to integrate this expression. So total work done will be integral of dw, that means integral of gmm by x square dx, And what should we take as the limit? We are bringing the body from infinity to point P, which is at a distance r. Now we can take out the constant terms, that is gmm. So we are left with 1 by x square dx inside the integration. And what is the integration of 1 by x square? Yes, you are quite familiar with this term now. Integration of 1 by x square is minus 1 by x. So these results you should remember from the limit infinity to r. So when you substitute the limits, what do we get? Gmm, minus sign you can take common. So it is 1 by r minus 1 by infinity. And what is 1 by infinity? 1 by infinity is 0. So the work done we get as minus gmm by r. So you can say that by definition we know this work done is equal to gravitational potential energy. So potential energy which we represent by U is given as minus gmm by r. So this is your expression for gravitational potential energy. Now this is the expression for gravitational potential energy. U is equal to minus gmm by r. Now here we have to remember certain things. What are these? Number one, the negative sign in the expression indicate that, now important takeaway from this derivation. Number one, the negative sign indicates that the force between the two bodies is attractive in nature. Number two, if distance r increases, then the potential energy also increases. Now what do we mean by this? It means that as we are moving away from Earth, the potential energy is increasing. Also, when will you have the maximum value of potential energy? When r is equal to infinity. So your potential energy will be maximum. Now third thing which we have to remember is, if your mass m is moved from a point which is at a distance r1 to a point at a distance r2, then change in potential energy will be given as delta U. Again we can use that expression. Instead of infinity we will write r1 to r2 gmm by x square dx. So when we substitute the limits, this is minus 1 by x, r1 to r2. So this is gmm by, this is 1 by r1 minus 1 by r2. So what does that mean? It says that, so when r1 is greater than r2, in that case your delta U will be negative, which means when the body is brought closer, what is happening to gravitational potential energy? It is decreasing. Now along with that we have to understand that potential energy is independent of the location of particle. It only depends upon the separation of particles. Also, if suppose instead of two particles you have three particles A, B, C, then you will have three pairs AB, BC and AC. So the potential energy of the system will be equal to the sum of potential energy of three pairs, which means suppose these are your three particles A, B and C. Let us say they have masses m1, m2 and m3, and the distance between them, let us say r12, this is r23 and this is r13. Then the total potential energy will be given as minus gm1 m2 by r12 minus gm1 m3 by r13 minus gm2 m3 by r23. So you have to first identify all the pairs and then you add the potential energy of all such pairs to get the potential energy of the system. And if you have n particles, then how many pairs would be formed? You will have n into n minus 1 by 2 pairs. So, to calculate the potential energy of the system, you have to calculate the potential energy of all the pairs and then find out the sum to obtain the total potential energy.